Hi friends, welcome back to my channel. Today we are diving into the fascinating world of Agentic AI. So let's start with some basics. What exactly is an AI agent? Simply put, AI agents are modules that are typically built on to perform a specific tasks. Think of them as a virtual helper that use AI or large language models to get the job done. For example, an AI agent can manage your emails by organizing your inbox and calendars. Another great example is GitHub Copilot, which suggests code and helps developers to debug. And nowadays it has become more advanced, like you can even tell them to shop for you as well. So, what is this agentic AI? What happens when a task becomes a bit more complicated in these scenarios? That's where these agentic AI comes in. Agentic AI is a set of modules combined together to perform a complex task. Unlike a simple agent, agentic AI has the capability to make decisions, take actions, and learn in order to achieve a specific goals. And agentic AI operates through four key strategies. One is knowledge, the ability to get data internally and externally. Second is reasoning, processing that data to understand the context. Third is the action, identifying and performing the next step based on that understanding which you collected the data. And final, learning, improving and adapting over time by learning from a feedback loop. Real world example of agentic AI includes self-driving cars and IBM Watson Health and much more. The features are very vast, guys. And moving on to the next, we have something called design patterns. What are the design patterns they use in the agentic AI? To build these powerful systems, developers use specific patterns. So let's look at them. There are mainly like four types we have. One is reflection. This pattern empowers agents to introspect and evaluate their actions or decisions. It focuses on iterative improvement. The flow is simple. The agent performs an action, collects the results, reflects on those outcomes against the predefined goals, and refines its strategy based on that reflection. Second, we have what are the tools we use in that. This pattern equips agents with external tools or APIs to extend their capabilities, allowing them to delegate specialized tasks rather than doing everything internally. The agent identifies a task, calls the appropriate tools with context, receives processed results, and integrates them into the workflows. Next comes the planning. Here, agents formulate and execute multi step plans to achieve a complex objectives. They define goals, analyze resources and constraints, generate a sequence of actions, and execute the plan while monitoring the outcomes. Next, we have a parallelism. It's a multi agent. This focuses on orchestrating multiple agents to work collaboratively. Tasks are assigned to specialized agents who share context or intermediate results, and their actions are orchestrated to achieve an overall objective. Finally, let's talk about the workflows. Workflows are the systems where LLMs and tools are orchestrated through predefined code paths. Here are six commonly used workflows. First, the basic building block, that is augmented LLM. This involves an LLM that supports building workflows complete with tool callings, memory, and retrieval capabilities. Second, we have a prompt chaining. Each LLM calls a process that output of the previous one. This is useful when the tasks are decomposed into a fixed subtask, like writing brief essay, introduction, and then elaborating on each section. Third comes the parallelization. This breaks the tasks into mutually exclusive subtasks for speed or provides focused attention on each aspect of the task for accuracy, just such as debating the pros and cons of open borders. Fourth, we have a routing. This is used for complex tasks with distinct categories that are better handled separately. For instance, a router can look at a document and send it to a different models depending on whether it's a generic, sports, or medical context. Fifth, we have evaluator optimizer. One LLM generates content and another evaluates it and provides feedback. This iterative refinement is great for tasks with clear evaluation criteria, like writing an article that requires multiple reviews. And finally, we have orchestrator worker. The main orchestrator divides a task, delegates it to a specialized worker based on the specific input, and then a synthesizer consolidates the results. For example, if asked a complex physics or biology questions, the orchestrator routes it to tuned models for those specific science, ignoring irrelevant ones like history. Remember, all of these workflows can incorporate a human in the loop, where user feedback helps decide the next step. So, thanks for joining on this introduction to Agentic AI. We'll come up with the next video. Until then, take care. Bye bye.